women will be considered tall if they are a little bit low value for height. So based on height and gender, consider we are classifying people into small, medium, and tall. So what the neural network does is, it will take the data for a person, particular person, height and gender, will give some weights to these values and pass on to the next guy. So this happens and the weights get updated, and when in the output layer, you will get a classification of whether the person is small, tall, or big. So this is the working of artificial neural network. Here the first layer is called the input layer, where we will be supplying the features. Here in this case it is height and gender, and next layer is the hidden layer, and last layer is the class label, which is whether the person is small, medium, or tall. So in the process of passing the input to output, there are set of operations that take place, and based on the probabilistic value, we get the correct classification. So this is the working of a neural network. And now, why deep learning has emerged is this artificial neural network is not able to process complex data when there is huge amount of data. So that's where deep learning evolved. Deep learning models are modifications of the artificial neural networks which are able to handle huge volumes of data, and they can automate complex tasks, and they are able to perform well in real world applications. That's how deep learning emerged from the artificial neural network. So if we compare machine learning and deep learning, in machine learning, suppose you want to classify an object, what it does is we'll be supplying some features, and feature extraction has to be done, and these features will be supplied to the learning algorithm, and the learning algorithm will classify an object into the category it belongs to. Whereas in deep learning, this feature extraction is not needed. You just need to supply a whole lot of data. The features will be automatically learned from the data, and classification will also take place. So that's the beauty of deep learning. Feature extraction is not necessary. It happens automatically in the deep learning algorithm. So when it comes to when to choose deep learning and machine learning models, is that when you have only small amount of data and you have well-defined features, it's better to go for machine learning models. But when there are massive volumes of data and you don't have feature extracted, then it's better to go for deep learning. And deep learning models perform high accuracy when you have sufficient amount of data, but training time is very large. You have to process huge amount of data, so there will be computational requirements as well, and it will be consuming more time. So this is what basically deep learning model does. Machine learning model, we have feature extraction phase where features have to be supplied and given to the machine learning model, and it will classify an object. Whereas in deep learning model, the feature extraction and classification takes place automatically through the deep learning model. Now these are some of the common deep learning architectures: convolutional neural network, recurrent neural network, NSM, and so on. So all these neural networks are convolutional neural networks are mainly used for image and video processing. Other neural networks are used in NLP applications and all. For example, if I say don't try to over spoil, still the system will recognize milk. Don't try over spill milk. So the word will be automatically recognized based on the previous word. So all these architectures, RNN, LSTMs are able to predict these kind of words and do the NLP task in a better way. I just explain about a convolutional neural network. Suppose you are supplying an input image. So the deep learning in the neural network means that there are a number of layers. There will be a set of layers. Each layer will be doing some particular task and extracting out some features, and at the end we will have the classification of what an object belongs to. So consider face recognition task. You are giving recognition. You are trying to recognize a face. So in the first phase, edges will be detected, then combination of edges, and gradually each layer will be extracting out some features, and finally recognition of face is done at the last layer. So this is how the convolutional neural network works. And this takes into account some operations that extract out features from the images that you supply as input. Now coming to the different applications of deep learning models, image and video recognition, as I said, we can extract face mask detection. Like from videos, we can recognize whether a person has worn a face mask or not. So that's one application. Then image recognition task, detecting of different objects. Then speech recognition and predictive analytics, making predictions like what could be the stock market price for the next week. So such predictive tasks can also be done when you have massive amount of data using the deep learning algorithm. Also, credit card fraud detection can be done. Then many NLP applications, natural language processing applications, can be done. Then supply chain optimization, recommendation systems, product recommendations, shopping recommendation, music recommendation, whatever we see in the day-to-day life is based on the deep learning application. Also, medical diagnosis, MRI, CT scans, all these can be done efficiently, which are hard to find by human naked eye, can be done using deep learning models, which will recognize anomalies in scan reports very easily. And the latest development in deep learning is the generative models, that is ChatGPT and large language models. These are also the basic architecture is the transformer model, which is again a deep learning model. And we know we can generate essays, poems. You can give write me a poem in Shakespearean language. You get a poem written in that language. So all these are possible because of the generative models, customer service, content creation, tutoring, personal assistance, anything, everything is possible because of the generative model. So earlier models like CNN, LSTMs are all predictive models where you get some predictions, whereas these are generative models which generate some content based on the amount of data that is being trained. Llama is the popular model that is launched by Meta in 2013, based on ChatGPT. It is the conversational AI which will generate text, and you can supply text or long papers and get summarized. So literature review has become a very easy task nowadays. You have to just upload a paper to ChatGPT and it will give you a summary. You can have literature bindings which will give different papers. There are so many applications so many tools that are built for making the research easier for researchers. Another model-based generative model is Gemini, which is a proprietary model by Google. Again, combining the text and image understanding and doing complex conversational AI, image analysis, content creation. Now, single model AI means you are supplying a single data type to a model, and it will give you some content generated, like NLP does. If you are asking a question to a ChatGPT, you will get the response back in text. So that's single data type. Now the trend has moved to multi-model AI, where you can give different modalities of data, like you can give text, graphics, you can give graphs, bar charts, and give to an LLM and get response and content generated. So this is the recent trend, that is multi-model AI, which will help you generate a variety of outcomes based on different types of data that are supplied. These are some of the interesting applications of multi-model AI. You can have an interior design assistant. Like if you are building a house, you want to have interior design, you can give suggestions that will generate an interior design for you in the way you describe. So that's one interesting. Then handling multiple images. So this is you can give multiple images of say some hotel bills, and you can ask what is the total amount of this bills. This is also possible. The system will learn data from extract data from all the bills and combine and do a summation for you and give the total amount. And comparing nutritional amount, you are supplying images of say some drinks, health drinks, and you want to know the nutritional content of the drink. it will again extract out the nutritional facts and suggest you which is good for health. And know your fridge. If you upload the image of your fridge and you ask what recipe I can do today, again it will give you a response like that. Is there banana inside my fridge? It will give a response like that. It can literally extract the images and query answer whatever queries you click based on the image data. An image tool called if you give a picture where is this place, what is the current weather at this place, you will get answers. So literally you can give any image and get queries answered using the generative model. So this is what multi-model LLM does. Different modalities of data can be combined and contents can be generated based on the user query. And there is one more tool that is DALL-E. This is another tool which can create images from text prompt. Like so, this is an image generated by this DALL-E. That is, I want a coffee shop with a very nice ambience. So it has generated an image like this. So not just creating new images, image editing can be done. This can be integrated with ChatGPT. So different possibilities are there. Manipulating with images, that's the tool which is DALL-E. Another technology that is commonly used in industries is the retrieval augmented generation. So what basically LLM does is, LLM is trained with so much of data, that is text documents, and if you ask a query, the LLM will generate an answer for you. That's what we know. But the answer can be sometimes wrong. Even if it is wrong, we get a beautifully crafted written response from the ChatGPT, right? So how to overcome the limitation of the ChatGPT? You can have better responses and correct inferences through ChatGPT by this technique called retrieval augmented generation. So what this does is, we can have some external source of data. That is, we can have so much of data or documents that is fed to the LLM. So when you ask a query, these documents will also be referred and the answer generated can be more accurate. So this is a technology that is being adopted in industries for increasing customer queries and customer satisfaction and all services. So here we are making use of the basic LLM model. Along with that, we are supplying some authentic documents. We can add as many documents as you want, and based on that, the content will be retrieved from that document, and the query, the answer responses will be more accurate. So retrieval augmented generation or RAG has so many use cases like question answering, summarizing text, then knowledge retrieval in chatbots, personalized recommendations, content creation. All these are really useful use cases of RAG. And these are some of the recent developments, the latest versions of the multimodal models of generative AI, GPT-4, DALL-E 3, and there are ethics bias that already Minima has explained, that the ethical concerns that arise when we use ChatGPT and all. Like I have written a poem in Shakespearean language and I am claiming that it's my poem. The very notion of authorship analysis is at stake. Anybody can come up with a story, a poem, and claim the authorship, right? So it's difficult to trace out whether it's written by a person or it is generated by ChatGPT. Then tiny ML models, as you know, these LLMs and deep learning models require high computational power. So how to reduce the computational power and use them in resource constrained environment? That is the scope of tiny ML. Making the models run in resource constrained environment. That is, if your computational resources are very limited, you can go for tiny ML models. That is also a recent development. Then federated learning and privacy preserving model. Privacy is a very state zone. We are being traced everywhere. The data is being used for LLMs and all models out there. So how to ensure privacy at the same time? Build robust models, that is again another concern. Then automatic ML. ML models require large amount of experimentation to fine-tune the model and give accurate results. So how to fine-tune these models automatically? That is another branch of study, that is auto ML, and tuning the parameters. The parameter tuning is what determines the accuracy of the model. So this all the recent research development. And the challenges is, as I told, the high computational requirements, also the availability of data. That is, in finance data, health data, all these are sensitive information, and it is really difficult to capture such data for doing the machine learning task, deep learning task. Then transparency and explainability. We don't know how the models are working. It's like a black box. How to interpret the results, how the data is being captured, how authentic the result is, how the model come up with such a result. All these belong to is what explainability means. And there are obviously ethical concerns when we share sensitive data, when we run experiments on sensitive data, patient-sensitive data, and all. There are ethical concerns, and basically there are privacy concerns also. That we are using sensitive information of people for learning. So how to ensure privacy at the same time with robust models is also a challenge. And we at LTS Institute, we are doing a collaborative project with the LTS Center for Disability Studies. We have undertaken some projects for disabled students, that is sign language recognition. So basically the problem with sign language is that only few words can be represented in the form of static gestures. Say letters, and very few words can be represented using static gestures. For communicating with speech impaired people, if you are using sign language, it generally requires usage of hands and facial expressions also. So recognizing such language is something that we are currently working on. And another is for speech impaired people. That is hearing impaired people. They don't know how to pronounce words. So speech therapists train them, they find it very difficult to train them. So how to understand the words that are being spoken by such people. So that's again another project that I am currently working on. So all these require a huge amount of data, like the sensitive data operation of the people, and highly sensitive data, and the consent of the subject that we contact. So these are some of the models that we are working on for disabled students at LTS Center for Disability Studies. And so that's all about. If you have any queries, I'm happy. The data collection process only. We are contacting the Jagadi Deaf School and NISH. So we are in the data collection process only. We have to capture the videos from subjects. Like if you want to say a sentence, it could be some combination of facial expression and building chatbots and building these models.
Generative AI is that, they made it very simple. Anybody can use it. That is the advantage of this one. You don't have to worry about whatever technology they are talking about. These are all for others. But generalists, any person X and Y can simply use it for their productivity increase. Okay.
So as a college teacher, what I face difficulty is that earlier we used to give assignments which are not there in internet. We'll draw new diagrams, give new values so that they are forced to solve by themselves. But now they can just give any image to ChatGPT and get the problem solved. There is no point in creating our own questions.
Any more questions?
We are using the Google search engine for finding out certain queries, because we are now in the era of knowledge. So Google search is the easy handle for us, for persons like us. So I am giving a text, text. I want a best image for this kind of a coffee shop. So this, when I give the question, images are coming. So that is using artificial intelligence, isn't it?
Yes, sir, yes. You can give text and you get the image generated.
So many images are coming. lot many images will come.
You can add as much details as you want, and you will get the image generated based on what you ask.
So everything what is given in Google search, it is all.
So all the data has been trained with this model, and as long as you are supplying more and more data, you will get more and more better results.
Okay, thank you. Augmented generation.
Yes.
Which you give some documents, a lot of books. So how you will input these books?
So basically, we have to we need the LLM model. And we have to supply these books in a database, or you can store in files as files, and all these can be stored in a data store, and the ChatGPT will retrieve data from the external source and generate better content.
You need to know whether it should be scanned and provided. Is it to be scanned page by page?
Not scanned, not necessarily scanned. It can be stored in a database, or it can be available as a normal document.
I have a physical book.
So that image can be scanned.
We need to scan.
Yeah.
Scan it and provide it.
It can be converted, scanned, and then it can be converted into document, and it can be used for retrieval.
As a threshold to the system, I just use only ChatGPT. Is this retrieval augmented generation can be done using ChatGPT?
Retrieval augmented generation is a technology to enhance the ChatGPT.
It's
being used in industries for manipulating, for extracting data from their databases also.
I have heard about that manuscripts can be, it's legible.
Yeah, that's how we can build our own chatbot. We can supply our own document which is not already trained in the LLM. Say if you have your resume, you can upload it to ChatGPT and ask questions from that.
Language is not a problem.
Language, I think it's not available in regional language. Multilingual, yes. Multilingual support is not fully functional.
And it was a nice presentation. I need the slide of this. Slides, presentation. Something, can it transfer to the test the image? You think, only we are thinking only, test our image. Is it possible to see the computer as image?
I think it is a
If we think something, we are not typing.
Think something.
Thinking and images are just. So is it possible to transfer?
possible. So that's different technology. Brain computer interface, brain signals can be analyzed.
Yeah.
So as such, generative models and AI require text or images as input. Our thoughts cannot be processed. That's again another area. Brain computer interface is there. That's what treating Alzheimer's patients are.
No, it's again one more. It's the last question.
Charts from data for interpolation or extrapolation of predictions, then the accuracy is easy, or what is the accuracy levels? What are the accuracy levels?
You mean generating data tables from charts?
Yeah. Because
That's
future and previous generation.
So currently multi-model LLM support that feature. From charts data table can be constructed, and we have to experiment on the accuracy. Also, math grading is also possible. If students have done some mathematical calculation, and if we give to LLM, it will evaluate the answers and say which all are correct. So that's possible for basic calculation, addition, subtraction, and all. Not sure about like transforms and mathematical.
Okay.
But for simple math grading is there, tutor is there. So if you upload math questions done by a student, it will evaluate and say these answers are correct. That's again another aspect of this multi-model support, which is in the latest model 3.0.
Okay, thank you, Mani. It's
Good point,
concluded by
yes.
receiving a memento as a token of appreciation and good presentation for this seminar. Thank
Thank you very much. Now, the next